in the form of addition and subtraction of fractions. And in these cases, we're going to start by finding the least common denominator. So I'm going to start with number 18. Number 18. Number 18 on page 204. And the equation says x times x plus 1 over 6 minus x over 3 equals to 1. Is that right? Make sure I copied it right. And now, the first thing, if this had been a plus sign, let me change this for just a minute, and then I'm going to change it back. If that had been a plus sign, what would our next step be? We'd be adding and subtracting fractions, which is like the assignment for today, right? What you did for today was adding and subtracting fractions. So what your first step would be to find the common denominator, the LCD, which is 6. And then you'd have to drag that 6 for the common denominator all the way through the problem. You'd have to drag that denominator all the way through the problem. But because it's an equation, it's got an equal sign in it. And I want to emphasize that this being an equation gives you a whole new way to set up a problem. All right? And that would be to multiply both sides of the equation by the common denominator. You see, whereas before we had to keep that denominator all the way through the problem, step by step by step. Because it's an equation, you've got a left side, a right side, an equal sign in the middle. You can multiply both sides of this equation by the common denominator, which is 6. So I want to multiply this by 6, this by 6, and this by 6. And look what happens when I do this. The 6 divides out. The 3 divides out and goes what? 2 and 6 times 1 would be 6. And what that does, that gets rid of all the denominators. I call this the fraction hater's delight. If you hate fractions, we're going to get rid of all the fractions problem in the very first step. Look what's left here. X times x plus 1. What would that be? X squared plus x. And then what? Minus 2x equals to 6. Okay? Now, what is it we call this equation with the x squared? Quadratic. And the next step, if it's quadratic, you're going to get it equal to 0. And while we're at it, we might want to go ahead and combine like terms here. What would that be? X squared. Now, it's plus 1x minus 2x would be negative x. And we got to get that 6. Do what? Negative 6 to both sides?
Yes.
And that would give you x squared minus x minus 6 equals 0. And guess what? It factors. And I tell you what, every problem in this section factors. Guaranteed. So what would you have? X times x, and then what about the 6? 3, 2, make it a negative 3, and a positive 2. So therefore, x equals 3, and x equals negative 2, right? X equals 3, and x equals negative 2. Any questions on that? Okay. I had to get it equal to 0, so I had to get the negative 6 to both sides. And then I had to do these two together to get negative x. And then I had to factor the trinomial. Was the question on factoring? So you've got to have what times what is x squared? X times x is x squared. And what times what? What times what would be negative 6?
Why do you always flip them when you're trying to flip them?
Well, sometimes, let me put an extra step in here. If you have trouble with this x minus 3, x plus 2 equals 0, what I can do is split the board in half. Does that help any? Split the board in half. Once you get it factored, then split the board in half, and instead of having x minus 3 equals 0, or x plus 2 equals 0. You've got two small problems instead of one big problem. And then you have to solve for x, which would be to add 3 and add 3. So x equals 3. Over here we'll subtract 2, and you get x equals negative 2. So it's x equals 3 and x equals negative 2. Put a mark by that and ask me after class. Okay? Really. Now, there's another problem I'd like to do, number 19, the one right after that one, number 19. So, number 19, on this section, number 19, it says x divided by x minus 5 minus 13 divided by x minus 2 equals to 15 divided by x minus 5 times x minus 2. And what do you notice happens on this problem that didn't happen on the previous one? Variables in the denominator again. You notice I've got variables in the denominator. Are there any forbidden values that you'd like to kind of set an alarm for? First of all, the LCD for the whole problem, let me write this down. The LCD is going to be x minus 5 times x minus 2, isn't it? That's the LCD for the whole problem. And the forbidden values are what? X cannot equal 5 and x cannot equal 2. Those two are forbidden values. So now, is it an equation? It's an equation. It's a fractional equation. It's got an equal sign, it's got a left sign, it's got a right sign. So I can use my little, what I call the fraction hater's delight. What do we do to get rid of this denominator? Multiply both sides by x minus 5, x minus 2. X minus 5, x minus 2, x minus 5, and x minus 2. Now, what happens in the first position? The x minus 5 divides out. The first fraction, the denominator's gone. In the second fraction, x minus 2 divides out, and the denominator's gone. What about the third fraction? Both of them divide out. So it's all gone. What's left in the problem? Multiply it out for me. X squared minus 2x. Now, let's see if you're going to be careful on the next step. Got something to remind you to slow down about here. Remember my little caution sign on the negative 13? What's this? Negative 13x, and then what? Plus, good. You remembered 13 times 5, which would be 65, equals to 15. Right? Okay, now what? Combine like terms, and that would give you x squared. These two combined, don't they? These two combined, that would be negative minus 15x. What do we want to do with that 15 down there on the very end? You see, these two are combining like terms. Negative 2x and negative 13x is negative 15x. Right? Got that? Did I lose anybody there? All right, how about the 15? We want to get rid of that 15. So let's do minus 15 to both sides. And that would give you a plus 50 equals to 0. Okay? Now, does it factor? I think so. Did I promise you that every one in this section is going to factor? All right, it sure will, unless you make a mistake. So if it won't factor, it's because you did something wrong, not me. Okay? Not that I didn't originally, but by now my errors have been found in this book, and so they should all factor. This is going to be xx. What times what is x squared? Xx. And then what times what? What times what would be 50? 10, 5. Right. And they're both going to be minus, right? Yeah. Minus 10 minus 5. And you see, it's negative 5. The outer times outer is going to be negative 5x. The inner times inner is negative 10x for a total of negative 15x, right? And the last times is negative times negative is positive 50, so that all checks. All right, now, what do? Can you give me an answer? X equals 10, right? In other words, you zero this out. So X would have to equal 10. And what about this one? X would have to equal 5. But I said X can't equal 5. So the sirens and bells and whistles are going off all over the room, right? You caught that. You can't have X equal 5. So what happens to this 5 answer? Reject it. Because that 5 makes the denominator 0. It's not allowed. It's inadmissible. So what's the answer? 10. Now if I had some extra time, or if we wanted to take time, we could check this answer by substituting the 10. Every place there's an X, plug it in, and you'll see that it checks. But it will check. Just trust me. All right? Now, on the next page, that was number 19. I'd like to go over to number 23. Number 23 has an even uglier look to it, but it's not any worse than the one we just did. It just has an uglier common denominator. So let me try this one. Number 23. And this is on page 206. The problem says 1 divided by x squared minus 4x plus 3. Is that a minus? 2 divided by x squared plus 4x minus 5 equals to 4 divided by x squared plus 2x minus 15. Okay? So what's the first step? Find the LCD. We do that by factoring each denominator. So we've got to factor this into what? X minus 3, x minus 1, right? This would be x plus 5, x minus 1, and this one would be x plus 5 and x minus 2. That's pretty easy factoring. And now,
No, it would be x minus 3.
x, where? 3, yeah, thank you. Again, I was just checking. Okay, thank you for catching that. You know what? I was about to catch that. I really was. Let me show you what would happen that would allow me to catch this. Suppose I didn't catch that. Suppose I made an error, and I go to work this thing out. I'm trying to find the LCD. What's the LCD for this whole problem? I'd have to have what? An x minus 3, and an x minus 1, and an x plus 5. Now, I've already got an x minus 1, so I don't need another one, do I? And I've already got an x plus 5, I don't need another one. But that x minus 2 would have meant that I have another x minus 2 in my common denominator. And I'll tell you what, there's not a book in the country that I know of that has more than 3 binomial factors in a common denominator. When you find the common denominator, I've seen problems where a student on a test would factor something wrong and come up with a huge problem, a huge common denominator. They have to spend the rest of the test trying to solve that problem that they've created. But I'm telling you, I didn't put a problem like that on the test. I didn't put a problem like that in the book, and I don't think any authors in the country are sticking problems with that kind of a thing. So if you ever come up with more than 3 binomial factors on a common denominator, that means you made a mistake, you see? Which I did, right there. I made a mistake. That's supposed to be 3. And so that way the common denominator has x minus 3, x minus 1, x plus 5. So what would I want to do now in order to solve this problem and get rid of those awful fractions?
Multiply each one by the LCD.
Multiply each fraction by the LCD. That would be x minus 3, x minus 1, x plus 5. X minus 3, x minus 1, x plus 5. X minus 1, I'm sorry, x minus 3, x minus 1, x plus 5. And now what happens? The x minus 3 divides out with the x minus 3, the x minus 1 with the x minus 1. And all the denominators are gone. The x minus 5, x plus 5 with the x plus 5, the x minus 1 with the x minus 1, the x plus 5 with the x plus 5, the x minus 3 with the x minus 3. All the denominators are gone. What's the only thing left here? In the first fraction, we got a 1 times that. We got an x plus 5. Okay? And the denominators are all gone. Isn't that great? What's the second fraction going to have in it? Minus 2x. Be careful. Minus 2 times a minus 3 would be plus 6. And then equals 2. What's the third one going to be? 4x minus 4. Oh, did I forget something? Should I have indicated which values are not allowed, or will you just wait till the end of the problem and then remember to go back and look? It's okay, you can do it now or you can do it later. Anybody care? I don't. Well, I do. X cannot equal what? 3. X cannot equal 1. And X cannot equal negative 5. I think if you do it when you think of it, you'll be more likely to recognize it when you get down to the end of the problem. Okay, what now? Negative x, right? Combine x's. This would be negative x plus 11 equals to 4x minus 4. Okay? I just combine like terms. This is 1x and negative 2x is negative 1x. Negative 1x. And this would be 11. Okay, now what? Got to get the x's on one side. Anybody have a favorite thing to do now? Add x to both sides. Okay, let's add x to both sides. That would give you 11 equals to 5x minus 4. Now we got to get the plus 4 to both sides. That would give you 15 equals 5x. So therefore x equals what? 3?
Can't have.
And you can't have x equals 3. So we'll have to do what to this answer? Reject it. Reject. Because we said that x cannot equal 3. So therefore, 3 is not allowed. And if the only answer that could have worked is rejected, what's the solution? No solution. No way. Okay? All right, now, having done that section, let's go to page 207. And I want to look at literal equations. Literal equations. We've already done literal equations. This term, it's on